Thanks everyone for coming, and thanks for the host and organizer for having me here. This is a great honor for me to discuss my research with all the colleagues here, and not only today, but also in the coming days and weeks and months. So you see, today's topic is about the basic questions about artificial general intelligence. I'm sure you have heard about artificial intelligence or AI. You may wonder, where is this AGI come from? Actually, the basic idea is not that complicated to explain. Artificial intelligence or AI start as an attempt to build thinking machine, whatever you call it, right? That's the thing you're familiar with from a sci-fi movie and novel, and that's the dream, that's the overall goal. It turned out to be much, much harder than people expected. So as a result, say a couple of decades ago, the mainstream of AI researcher actually quietly turned the direction to usually to work on one special function or special capability, and still keep the name AI. And this clearly achieved many success, as we have been using them for many years. But at the same time, there are also clearly the limitation. Even if you're talking about the special function, many people realize that those functions are closely related to each other. So it's very difficult to actually do one very well without touching the other. So this divide and conquer has its strengths and weakness. So this will bring a group of people, including myself, to the conclusion that we need to go back to the original. But the phrase of AI has been given a different name. You have to respect the common practice. So what can we do? Some people suggest this phrase, which have been accepted by this small community, and we call it AGI. We add a word G in it to suggest that we're talking about the general purpose. So I think, very roughly speaking, you can just remember that when we talk about AGI, we are taking intelligence as one problem. On the other hand, the mainstream AI basically take it as a collection or a group of related problems which can be solved one by one. So just from this explanation, you can see this goal is much bigger, it's much more ambitious. At the same time, it's much more difficult. Okay? If you claim you're doing this, people will say, how can you solve this problem, that problem? Well, you're supposed to be doing everything, right? Yeah, that's the challenge. So there is also some similar phrase used in the field. Some people have called it strong AI, some people call it a human level AI. Each of them have a slightly different flavor and focus, but more or less, they're talking about the same thing. So again, we are going to go back to the thinking machine vision, which will be comparable to the human mind in general, in some sense. So that's kind of like where the phrase or the topic come from. Then what's the basic questions I want to discuss today? First, I think no matter what you do or how you do it, you need to give a more accurate specification about your research goal. Okay? Just say, oh, do it, build something like a human mind or treat intelligence as a whole. Well, that's not enough as a research objective. Okay? You need to be more accurate. Talking about if you are saying that you build something comparable to the human mind, in which aspect? Clearly, it cannot be in all aspects, right? Because we are building something in a computer which is not biological, so clearly it will not be identical to the human brain or the human mind in all aspects. That doesn't make sense. So we're talking about one aspect, but which one? And you can still say it's general. What is that supposed to mean? The second question is, after you specify your goal, the second question immediately is whether that's possible. Okay, you have heard about this from the very beginning of AI. Many people say, truly, intelligent computer is impossible. They have tried different type of proof. They say they have reached the conclusion for this or that reason. You can pretend to be intelligent. You cannot be truly intelligent for this or that reason. So we need to answer that question. Especially you're talking about AGI. Many people say, yeah, you can solve one problem. You cannot be generally intelligent. How can we answer that? If we answer, we know what we are talking about, we think is possible, then we can talk about the third question, how to do it. And there are many different approaches. Clearly today, I will just talk about the major idea. And finally, there is a last question. Even if you know how to do it, whether you really want to do it. Okay, in recent years, again, I'm sure you have heard about this debate. Some people say we don't need AGI, it will make everyone lose their job. Some people say it will dominate the world, that will terminate human beings, blah, 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 blah. And clearly we are aware of those concerns. What's our answer about that? Okay. To me, even though I'm talking about AGI, I think this four question actually can be asked to any research topic. What are we talking about? Whether that can be done or not, how to do it, whether you want to do it. I think this is quite general, but also because it's quite general, there's no way for me to touch all aspects in 45 minutes. Okay? So I will talk about the major idea, the representative idea. Also, then I will quickly summarize my opinion on that topic. So I will leave all the detailed discussion for the future since I will be here. So that can be done. First question, what is intelligence? Well, that debate was there already before AI was formed in psychology for a long time, right? It is still continuing. In this case, as I mentioned, we're talking about, we're going to compare a computer system to the human mind. And we say they are the same in a certain sense. But clearly, it cannot be in all the senses. What's the representative opinion? First one, quite obvious, we should simulate the human brain. Okay. I'm glad to learn that there are a lot of interesting research happening right here in that approach, which is clearly very interesting and also well justified, right? If you know how the brain works, then you just do the same thing in a certain sense in a computer. So that's brain modeling. But we need to be aware of, if you are not, that's not the only possibility. Some people say, yeah, brain modeling is interesting, but is it really necessary? Maybe we can just reproduce the behavior without the brain structure. Maybe we can find another way in computer to do the same thing, maybe even faster. The best known opinion in this group is, of course, the Turing test. And now I guess everyone knows it, even the people or even watch it in a movie or somewhere. So that's the idea that you can just somehow reproduce the behavior. And this approach, of course, is also controversial. Some people say, yeah, that's good enough. Some people say, no, that's not the way to go. I'm not going to analyze the detail. I just show you this clearly is different from the first group. Guess what? We have a third one. And this approach say this is more come from the people who major interest is in application, is in solving concrete problems. We just want that problem solved. That problem traditionally can only be solved by the human mind. Now we want to use a computer to solve it, or maybe even do better. And whether it's solved in the human way, whether it looks like human, I don't care. I just want the problem solved. Okay? For example, AlphaGo played the game Go and beat everybody, right? And the self-driving car, it doesn't have to drive exactly like a human driver, but as far as you can move the car from one place to another safely, that's driving. That's what we want. Okay. So this is actually a larger group within the AI research. And they are doing all kinds of expert systems, or if you do not use that name, it's still special purpose system which are evaluated according to its performance certain problem. How is it related to human? It's just because that problem was solvable by human mind in the past, only by human mind. And whether this computer is doing it exactly in the same way, it doesn't matter to them. Okay, you cannot say this is not justifiable. It is justifiable, but clearly it's different from the previous. And we have a number 4. Some people say, yeah, if you just do it, solve this problem, that problem, and so on. What is a factor that put them all together under the name of intelligence? You must have something in common, right? So this is what, if you pick up artificial intelligence textbook or a textbook of cognitive psychology, it's more or less the same. If you go through the chapter title, you will see, okay, they say, oh, intelligence means the ability to do, say, learning, reasoning, planning, recognition, and so on. Just like human, because a human can also do the same. So this is basically the approach taken by theoretical researchers, people who are interested in building some theory about AI. And they see intelligence as a collection of cognitive functions, which we observe in the human mind, and we want to do the same in computer. Okay. Clearly, it also makes sense. And finally, there are people ask, okay, we can ask the same question, what's the principle behind all those functions that relate them together? We can call them intelligence. Just like many other domains, or every other domain, like in physics, chemistry, biology, you name it, you typically start from some fundamental function, then you build your theory on top of that. Okay, what is that principle or basic law behind intelligence, or is there such a thing or not at all? So there are also people pursuing this approach. So this is not really my discovery, even though the category is something I kind of use. Okay, everyone in the field know that under the name of AI, people are doing different things. But one key point I want to stress, which is very often missing in this discussion, is how are they related to each other. Some people will debate one is the right meaning, the other is a wrong meaning. That's clearly a little bit too far away. Some people say, no, we are all good, okay? And each of them are just different aspects of intelligence, which of course is correct. But we should do it together, and then some people use the metaphor of blind people and elephant, right? We may be able to build a whole system. Also, some people use, say, the metaphor, say, every road go to Rome, right? You can do it, whatever. What they are missing, I think that's a wrong idea. What they're missing is, I want to stress, is to me, each of them are valuable research, but they point to different directions. Okay. Accurately speaking, they're different disciplines, even though they share the name of AI for historical reasons. Are there any overlap? Of course, there are overlaps. But their final goal, their milestone, their evaluation criteria, all the other things are very different from each other. Okay? We should learn from each other. We should work together with each other, but do not confuse the goals. Okay. So that's the point I want to make on this topic. Then, of course, what's my working definition? I belong to the last category. I mentioned I'm still looking for a unifying principle behind almost everything related to intelligence. Okay, the principle I find is I see intelligence as a form of adaptation, but a special form which happened within an individual system's lifetime, and also there is a restriction that the system must be able to work with insufficient knowledge and resource with respect to the problem we want to solve. Meaning that the system does not know everything it needs to know to solve that problem well, and it doesn't have all the time and space, or it never have the time and space. Clearly, I'm pushing this to the extreme for some simple question. Of course, we do have sufficient knowledge and resource, but that's not the interesting one. The one we really need intelligence, and the one that we don't know how to solve. And also, we don't have the time to try all possibilities. So, to be more specific, what do I mean by insufficient knowledge and resource? I summarize 3 properties. One is the system has finite processing power, say storage space, speed of processor, number of processor, and so on. No matter how big, it's fixed. It sounds like common sense. Why do you want to mention it? Well, that's of course clearly true for every practical computing system or device. But if you check the theoretical models, few of them take that into consideration. Second, it needs to work in real time, meaning that the new problem will appear at any moment. It's not appear only when the system is idly waiting for a new problem. It may usually happens when the system is busy with something else. Then there is something happening which needs the system's immediate response. What can you do with that? We have to, but how can we build a computer system to work in that environment? Finally, open to new information. This sounds also trivial. Well, you can always load the data into it. But here, open means without any restriction to the content of the information, which means you can tell the system which directly contradicts to its previous belief. Then will that crash the system? And also you can ask the system a question that beyond its current capability. Will the system just go mad or just simply say, I don't know? So I want a system that can work with that situation. So it immediately follows that if you want to build something working in that environment, even if you're working in a certain sense, clearly there is no way for you to always expect correct answer or optimum solution. Cannot be guaranteed, just because of the definition I just introduced here. But what you can do? I think the solution is adaptation, which is a familiar word, but we need to analyze what it actually means in this context. I think it means two things with respect to the 2 points I just made. With respect to insufficient knowledge, adaptation means the system have to use its own past experience to make prediction about the future, even though the system itself and the designer both know the future is different from the past. But there is nothing else you can depend on. Okay? If that's the case, then what can you do? Time, resource, I'm typically talking about time. Okay? As I said, you never have enough time. That's my assumption. Well, if that's the case, then what can you do? You have to distribute it, your time resource, or allocate them in a meaningful way among the demands, even though you know you cannot satisfy all of them. Because I already put that into the definition. Okay? That's what the intelligence have to be able to handle. So how? Well, that's a separate story. Okay, at least I show you this is what I want to do. So this is a simple diagram which can intuitively show you the difference between my definition and the common definition out there. The common definition is still to measure intelligence in terms of what problem we can solve. Okay, so it's problem-solving capability, intuitively speaking. Or let's say if we can give a computer a score in terms of its performance at a certain problem, which here we just don't go into detail, just abstractly say that I can give the system a score, okay, to indicate its performance in problem solving. Then, according to the everyday or common judgment, the higher that level is, the more intelligent the system will be. That's how it's evaluated. Okay, but to me, you'll see that. To me, that's not really what intelligence is really about, or at least my version of intelligence. My version of intelligence is really about how that measurement is related to time. In this case, I distinguish 4 different categories. The first one is what I call computation. Here, computation is used in the sense of Turing computation. It's in the theoretical sense. It's not in the sense of whatever you do with a computer. Okay? In theoretical sense, a computation is a fixed mapping from input to output. Has nothing to do with time, has nothing to do with history, have nothing to do with context. Okay, you always use the same algorithm to handle the same problem, get the same result, use the same amount of time. That's what Turing machine, how computation is defined in theoretical computer science. So in terms of a function of time, you see this is a straight line. It's a horizontal line. It doesn't change over time. And where this line is doesn't matter. Okay, as far as it's a horizontal line, and that corresponds to a constant amount of constant level of problem solving capability. Okay. The second category is the recently popular machine learning system, which learns clearly. That means its score on that problem improve over time, but it will converge to a computation, or the learning rate will decrease over time. Okay, all the machine learning algorithms we have seen, most of them satisfy this. And finally, this is what I really want to do. That's what I call adaptation. Okay, actually, previously I also call it learning. But later I see learning also get a loaded meaning by the machine learning community, just like AI has been something else. So I pick adaptation, even though learning may be better if we take it in the original sense used in psychology. Okay, in that sense, learning does not converge to a fixed input-output. We learn all the time, even though on one concrete scale, maybe you say, I have learned that. You don't continue to improve. But overall, that's not the picture. Okay. So of course, here we are talking about a highly idealized, simplified situation. So it's kind of like the learning rate is a constant, but in reality, of course, it's not. But it's going on. And finally, there is another category you see I put between quotation mark. That's in recent years, some people talk about the superhuman intelligence. It's kind of like not only the score itself increase over time, even the learning rate is exponential increasing. Short answer is I don't believe that can happen. Okay, I have a lot of arguments, so I don't want to talk about. But today I basically use this to say this is traditional computation. This is machine learning. This is what we want to do. And here you'll see if you take that point, you'll see where is the intelligence measurement. It's in the derivative of the function. It's not the function value. That is why we have a lot of traditional AI system and machine learning system which can do much better than human. We still have the intuitive feeling. It's not intelligent. Why? Because I believe deep in the heart, everyone actually is talking about this growth rate. It's not the value itself. Okay. When we talk about humans, these two are correlated because we start more or less at the same point as a baby. Okay. If you can do very well, that means you can learn faster. But as soon as you extend that category concept into computer can cheat. Okay, you can build a lot of things into it, then it will stay the same all the time. They do better than you, but it doesn't learn at all. So I try to convince people this is a better usage. I'm not saying the other meanings are wrong. There is no such a thing as right or wrong for the meaning of a word. I would say this is a more proper usage of what intelligence means. Or in other words, at least that's what our team are doing. Okay, we respect the others, but we say that's a different problem. So is AGI possible? The first answer, of course, it depends on which version are you talking about, right? All those 5 categories I just mentioned, you can talk about whether this is possible, this is possible, this is possible. And one answer, the answer to one of them does not apply to the other. That's also a common confusion in everyday the current debate about AI. Very often you find that these 2 groups, they're really not talking about the same thing, even though they use the same phrase. Okay, they say this is possible, this is not possible, but they're not talking about the same. So the first thing I want to say is you need to talk about which one. And second, intelligence, according to all the 5 categories, if you check carefully, is still not a yes/no matter. It's a matter of degree. Okay, so we are not really talking about build something which is exactly the same as a human. We say they're close enough. So this probably a question about whether it's possible or not actually should be put in a better, more accurate form. That is how close these 2 can be. Okay, it's not completely possible or completely impossible. So I think that's the better question that can be meaningfully discussed. And also, this is argument usually used by people who believe it can be done. The argument is just like everything else. You know, use computer, as soon as you learn, you study this process well enough, as soon as you can specify it accurately, you can realize it or simulate it in a computer. So why intelligence is different? Many people put it that way. Personally, I don't think it's a strong argument, but it's a valid argument. So this part is kind of like in favor to say AGI is possible if you clarify it properly. But I'm not saying that the other side has no meaning. Clearly, there are some restriction no matter what you do. The first principle, no one mentioned it, but it's always there. We're talking about computer. Okay? We're not talking about, say, biological engineering or anything like that when we say artificial intelligence or general or not. Okay. A computer is not biological, so the biological features will not be there. If you simulate it, there is a degree of accuracy, and also there is a fundamental difference between a realization and a simulation. Okay. I can simulate a hurricane within my computer, but that will not blow away a piece of paper I put here. Well, that's a simulation. We understand that. Okay. So this, I think, is a more fundamental thing people tend to ignore when we talk about the limitation. Even if you can simulate everything within a mind, a lot of things about human actually is determined by its experience. And if you really want to say, oh, I can also simulate that, you're talking about to simulate the whole world. Okay, how about social experience? Without that, can we just be as who we are at the moment? So, yeah, a big topic. I don't want to go into detail, but I want to mention that. And also, yeah, I already touched this. Every simulation, if you take the point that AI is a simulation, and there is always an issue of accuracy level and the scope of the simulation. And this is basically my argument I tend to use. Because according to my definition, the real limitation of AGI, at least the version we are working on, is insufficient knowledge and resource. It will also make a mistake, a lot of mistake. It will be biased by its own experience because there is no way for you to go beyond that. It will miss some opportunity because there's no way for it to evaluate all of them. Even if you put in a supercomputer, even a quantum computer, I believe the fundamental difference restriction will always be there. Otherwise, we're not talking about artificial intelligence. We are talking about artificial God, okay, who already know everything, who doesn't need to be intelligent, who doesn't need to think, who simply know. And that's actually the version that super AI, superhuman intelligence is talking about in a sense, which I don't think is possible. So how to do it? If you buy the argument and say, yeah, no matter what you call it, I think it's possible. That's what we debate about within the field. Of course, everyone has its own approach, which are more or less different. First, again, it depends on what you mean, right? A different goal clearly demand different strategy. And also, I think I should mention here, when we are talking about AGI in the current context, we're talking about two very different community, research community. One is the one that I belong to, which we start to use the phrase of artificial general intelligence about 20 years ago, without the knowledge of the world. It's a very small group of people who believe this original dream of AI deserve to be pursued, even though most people don't think so. Okay, and over the years we have been growing with our own annual conference. We just had this year's conference in Seattle, and with our own journal and so on. But after so many years, it's still a very small group without the acknowledgement of most of the AI researchers. But on the other hand, in recent years, there is a much more influential group, which basically come from the bigger companies, especially DeepMind, OpenAI, Facebook, Meta, and so on. Most of them currently talking about AGI. But these two communities actually also use this the same phrase in very different sense. The big company basically doing deep learning, even though they're thinking about other things, but they're mostly deep learning based. This small AGI community, deep learning play a much smaller role. We know deep learning from the beginning. We don't think it will solve the problem. We think it's a useful tool for some part of it, but it's far from the core technology which will give us intelligence. Okay, I can explain the detail later if there's interest. And also what this G means, general purpose. Again, some people claim, especially deep learning people, say that this is already general purpose because deep learning can be used in many different domains. And that's of course true, but that's not what we mean. We mean one system, okay? Not that you build one system here, another system here, another system there, and you call yourself. And that's a general purpose technology. Is not a general purpose system which can handle, by the same system, can handle many different problems. Okay, that's one key difference to remember. Another one is also a common misconception that people say, oh, there's no AGI. Even humans are not generally intelligent. And there's no way for you to build a system to solve all problems because each problem needs different solution, okay, with different property and so on. That's true, but that's not what we mean, or at least that's not what I mean. Here, general purpose system in my context means it's not designed for one thing. So this also is implied by my previous keyword open. So I can always get new problem, but of course I cannot promise you I will solve all of them. At least I will not be crashed just by an unknown problem, or be trapped into some combinatorial explosion, busy about without ignoring everything else, just working on something which is completely hopeless for me to solve, just because I don't have the knowledge. So that's what I mean by general purpose. Okay, it's not mean that to be able to solve all problems to some according to some standard. That is impossible. Okay, according to my job. But that's not what we're working on. And that's clearly not what the human mind is. So different strategy. If we want to do something, yeah, even according to my interpretation or according to some similar interpretation. Anyway, you want to be able to have multiple functions. Clearly, if you take a functional point of view, you want to do, say, learning, reasoning, perception, and action, and planning. And clearly, you cannot just write one piece of code and do all of them. So I see there's three major approach with or strategy. One is clearly the hybrid approach. Basically means that from the current AI, all the functions have been already achieved to a certain level. Why not just put them together? Okay, that's something some people promoted in recent years. Say just let's work together, right? Put our result into one system, then we get a general purpose system. Sounds very meaningful, but if you actually try it, you will know it doesn't work. Simply because all the pieces have been developed under very different, usually incompatible theoretical foundation. You can put them together to solve one problem. Usually that actually may happen. We did that by ourselves. For one special application, you do a customized system, use multiple technology, each cover one piece. But it doesn't work for AGI because you cannot customize this combination for every possible problem. Okay. But if you just simply throw all the technology together into one system, well, of course you can code them in one system, but they are not going to work together. Okay. So the next approach is what I call, many people call integrated approach, which means that, yeah, you can use multiple pieces, but you need to start from an overall blueprint or architecture. And then each of them will do a thing and also coordinate with the others according to the data. This clearly makes much more sense in this context. And finally, there is a more extreme position, say that we just use one technique, but we are going to gradually extend it, the technique, from its bare form into a more and more complicated form. The difference is this one is based on a single theoretical foundation, even though you have more and more complicated performance. Okay. Again, which one is right, which one is wrong is too early to tell. Most of the AGI people are doing integrated or unified. And some people in the mainstream AI, but they claim they're doing AGI, is talking about this approach, but I haven't seen any real progress. Okay. It's just because, yeah, if you want to be general, for cognitive architecture, there is already a long tradition. Many different things you will see like this kind of diagram. Okay. Many small blocks or modules each carry out a certain function. You name it, wherever you pick a textbook in cognitive psychology, you say, oh, I want this, then will add a module, say, I want to do that. Then you'll say, okay, which one is related to which one? Which on one hand is very convincing, yeah, we do want those things. Yes, we do see the relationship. But on the other hand, it's very difficult from engineering point of view to actually make it work together. So that explains why I take that, again, the last approach, the unified approach. We built a system called NARS for a non-axiomatic reasoning system. You'll see that I'm using reasoning in a broad sense as the technique. But I built it over many different layers. I use a concept-centered representation to represent uniformly handle all types of knowledge, not only declarative, but also procedural, aesthetic, and so on. And I take reasoning as concepts substitution, meaning that you use one concept as the other. I'm not using reasoning in the current sense of theorem proving, which means from truth to truth, okay, as you do in mathematical logic. So my logic is very different from mathematical logic. As I have already said, right, in my definition, there is no absolute truth. So and also that's where the name comes from. There is no axiom, which is the truth value you can know for sure will not be challenged. Okay, everything can be wrong. If that's the case, then can you still do logical reasoning according to what logic? Well, that's the problem we have trying to solve. Okay, so my belief is even though under that situation, even though we know everything can be wrong, we can still have a logic which give us justifiable conclusion, even though it does not guarantee to be successful. Some people say that sounds like a contradiction, but according to my definition, well, I will explain in the future, it is not. Okay. And also, this is about resource. Basically, the basic idea, actually, there's nothing magical. Think about us. Okay, what we do if we don't have enough time? We do attention allocation among multiple tasks. And we adjust that dynamically from time to time as the situation changes. That's it. Okay, we do the same. We learn a lot from psychology, even though we do not duplicate all the details. So again, for the detail of NARS, we can talk about in the future. Now the last question, should we do it, even if we think we can? Well, yeah, the same answer. First, it depends on which version of AI you're talking about, okay? And what I mean is each of the five, as I mentioned before, has its risk and also has its way to handle the risk, but they're very different. So there is no such a thing that one version of AI will guarantee to be absolutely safe. There is no such a thing. I think that also applies to any other technology, not to mention major technical breakthrough. It's always a danger. Okay? What you need to do is just balance, just like everything else. You balance the benefit and the risk. You want to take that risk because the benefit is so big. Okay, so I think there is no difference here. What makes adaptive system different compared to all the other approach, machine learning, traditional AI, is, again, this is common sense. A truly adaptive system, its behavior cannot be fully determined by design. It, to a large extent, depends on its experience. Or in AI situation, it depends on its education. What kind of data you feed into it, in what order, under what condition. Just like how you educate a child. Whether a human is naturally nice or evil, I don't think that's a meaningful question. Okay, so if we want safe AGI, you want to raise it up in a certain way, not just to design it in a certain way. So some people expect us to design an AGI, guarantee that will not become a criminal. I don't think that can be done. Okay. But if you admit there is a risk, do you still want to do it? Well, I think we still have a lot of reason to do it. Theoretical reason, you see, what I've been talking about is not to build a machine to solve one problem. This, to me, is a continuation of the human history of study about what thinking, mental phenomena, and everything related to that. Okay, AI just provide a testing bed or lab for all the theories about thinking, include human thinking, into practice. Okay. For me personally, my interest is more on the theoretical part, not in practical application. I want to figure out what thinking is about. So the best way to me is not to read a lot of books which claim to have solved the problem, is to actually build it. Okay, if it works, then we know we have a theory. And this, I don't think anyone can argue that, of course, this is dangerous. But I don't think you can ban it. If you want to ban that, you will have to ban the whole psychology, logic, even philosophy, even human thinking, because it's dangerous. Okay, so that's my theoretical justification. Practical justification, you see, in my approach, my interest is actually not to replace human labor, not at all. I want the system to solve the problem that no human can solve. Because of the complexity, because of the special experience needed, because of the computational power needed. We are facing many such problems in our current society. We need help. Our mind is not enough to handle them. Okay. So to me, that's the practical reason that we want to do it, not just to replace human labors to, cause a lot of people out of their job. Well, some of them will happen, but how to make it safe and beneficial? Yeah, you see, there are a lot of things. You need to design it properly. Yes, of course, we do have some responsibility, but it's not all the responsibility because we cannot control everything. So the education, socialization, you need to, for example, you need to treat it well. Otherwise, they will hate you. Okay, that sounds weird. That sounds very normal. Okay, so that's not a technical issue, and also all kinds of regulations and laws and so on. So we don't have time for detail. But we are introducing new risks. I'm not avoid that at all. But on the other hand, I think we still have a lot of hope that human society can handle that. Okay, just like we have been able to handle a lot of other things, but not by a simple technique or simple solution. In summary, what is AGI? Actually, is the original AI. It just people later, change it to something else. Now we want to go back. We want to build a thinking machine. What's the major difference? Well, there are a lot of differences in technical detail, but the major difference is in the goal and in the strategy and methodology. Okay, and all the other differences are based on that. And is by nature is highly interdisciplinary, and also is still in its very early stage. There is no mature AGI theory or technique or anything like that. But we do have some interesting results already produced, even though we are far away from what we want to achieve. That's at least I think that both sides you need to take into consideration. And finally, for all the other information, I have a lot of papers and other things on my website. And also, as I said several times, I will be here to answer questions. Okay, that's all. Thank you very much.